Hello, everybody. I'm your host, Abid Samhouri, the lead of Axon Cyber Institute. This is episode number 7 of the Navigating the Cyberland series, coming to you on the second Thursday of every month, where we dive deep with hands-on demos into certain topics of cybersecurity. This session is recorded and you can replay it later on demand. You can also access the previous episodes on demand by going to app.livestorm.co/axon-technologies. The topic of today's session is going to be Active Directory Security, Attacks, and Countermeasure. Just before I move forward, please indicate in the chat that you can hear my voice clearly and you can see the shared screen. Okay, awesome. The topic of today's webinar is going to be Active Directory. We're going to dive deep into how to perform certain attacks against Active Directory, and in particular against Kerberos protocol, which is or Microsoft Kerberos protocol, an implementation of Microsoft in Active Directory. And we're gonna simulate different types of attacks, and we're gonna talk about mitigation strategies and security countermeasures at the end. This webinar will be accompanied as usual with some hands-on labs and demonstration. And our lab is gonna consist of 3 machines, 3 virtual machines. One of them is Active Directory Domain Controller. It's a Windows Server 2008. All the attacks are applicable even to the later versions of Windows servers, like 2012 or 16. We also have Windows 10 that is domain joined, and we have Kali Linux. Kali Linux is going to be our attack, and we'll try to perform some attacks against the domain, and we'll try to see how we can even access Windows 10 using some cracked account. And the domain in the lab is axon-ncl.axon, okay? And the main tool we're gonna depend on today's webinar or today's labs will be Mpacket, okay? It's a tool that is open source, available. It's written in Python. You can download it from GitHub. It's a package, it's a collective of tools. So it's a package of multiple tools. We will cover maybe 3 or 4 of those tools in today's presentation. The agenda is going to be like this. First, we are going to talk about, we're going to cover how you can footprint, how you can identify an Active Directory in your network, what things to look for when you try to, scan your network to identify if there is an Active Directory. Somebody is writing on the chat, there is no audio, there is no video. Please check your configuration, because as I can see, everybody else does not have problem with audio or seeing the screen. I have a PowerPoint screen that is shared. And then after that, I'm gonna talk about how Kerberos authentication actually works. We need to understand a few terms. Kerberos sometimes can come across as a deep protocol, very sophisticated. There are a lot of details in it. We will not go into a lot of theories of Kerberos. You can read it on your own, but at least we're going to talk about those important factors in Kerberos that will help us understand the vulnerabilities and the attacks, okay? Then we will talk about a couple of attacks, or actually 4 attacks. We'll talk about what's called AS-Reproasting. AS-Reproasting. This is the first attack we will cover, and then Kerberoasting, the second attack. Then we will see how we can extract domain hashes from an Active Directory. Now, of course, this assumes you have already compromised the Active Directory and you want to extract the hashes. We will see the ways to extract the hashes. And then finally, we will talk about the attack that's called Golden Ticket Attack. And the Golden Ticket Attack comes after extracting domain hashes. So you have to extract the domain hashes in order to perform the Golden Ticket Attack. And then finally, we will talk about techniques. Now, of course, these are not all the attacks against Active Directory. There are others, but these are the main ones and the most dangerous ones, okay? Now, of course, in 1 hour and a half, we cannot cover all the attacks, but at least at the end of this webinar, you will have a good knowledge in how to perform some form of pen test against an Active Directory. So let's dive in. How do we identify an Active Directory server inside a network? When you scan your network using Nmap, okay, we look for certain keys or certain factors. Number one, which is the most important thing, you need to find port 8080 open. And port 8080 is the port of Microsoft Kerberos, okay? Once you find this port open, TCP and UDP, but most importantly TCP, on a system, this is like 99.99, this is an Active Directory. This is or a domain controller, okay? So either domain controller or Active Directory is a domain controller, by the way. So if you find this port open, then that means it's an Active Directory and domain controller. Okay. Another thing is the LDAP port. Also, it comes with Active Directory 3268 on TCP. This is also another port to look for. I'm gonna make my pointer over here. And then once you have done your Nmap, you have to take note of certain parameters. Okay, these are the parameters we have extracted. I have extracted from me running Nmap against the current Active Directory, which I'm gonna do in a while. So you have to take note of the operating system. You have to take note of the computer name. What is the computer name you might use it? The domain name, okay, and the fully qualified domain name. So let us do the first lab here, doing some reconnaissance or footprinting on my machines. As I have told you, I have here 3 machines. This is Windows Server 2008, this is Kali Linux, and this is Windows 10, okay? So from Kali Linux, I'm gonna run Nmap, okay? So let us clear everything, the entire mess over here. So the first thing, I'm gonna run Nmap with certain parameters. So I'm gonna enable SYNSCAN, and then the version scan, and then the operating system scan, and the script, the basic script scan. Of course, you probably have done your own host discovery, and then you have, at least you are targeting each live host. So in our case, we have one live host, and that is 127.250, which is the IP address of our Active Directory. So we have to leave it for a while, and then we have to look for those signs that I have already mentioned. Once you got that, you can even refine your Nmap and try to do something extra. And that is and one thing we need to do is we try to enumerate users. Okay, once you have identified an Active Directory, let us dive deep now and try to extract the usernames. We cannot really extract usernames, but we can do username guessing. Okay, so if you have a dictionary, okay, with a list of usernames, you can attempt to figure out which of these usernames actually exist on that Active Directory. And Nmap can do that using a script called kerb5-enum-user. This is a script, and then you give it some arguments, especially the realm, which is the domain name. It has a built-in account. It has a built-in list of username, which you're going to attempt, or you can give it your own list of usernames. And in here, I have a list of, so I'm going to leave the scanner running on the other tab. In here, I have a list of usernames. This is the file usernames. So I have compiled it with some random usernames. And once the scan here finishes, I'm gonna run this this list against the Active Directory to figure out which accounts of these exists. Okay, so the more exhaustive your list is, the more accurate your results is going to be. So let us wait for the Nmap now. Something else I have to tell you regarding the cracking of usernames. Now, one thing you can do is once you have identified certain username, you can crack its password, but this is risky because of a lockout mechanism. But we're gonna see other techniques of cracking passwords. So the results here have finished. The results here have finished, and let us look here. Now, simply by looking at the results, Microsoft DNS, Microsoft Kerberos RPC, this is a Windows machine. This is number one. Second, we have 8080 open. So this means it's a Kerberos, it's a domain controller. And we have LDAP open, which is, again, it's not only a domain controller, but in addition, it's an Active Directory where it has a list of all usernames and password and services. Okay, and if we go a little bit down here, device type running Windows 2008, we can go a little bit down here. OS details, we have Windows Server 2008 or Windows 8. So this is as close as Nmap can get. Again, we have the NetBIOS name. This is the NetBIOS of the Active Directory, and this is the domain. This is the fully qualified domain name. Let us try to enumerate now what users do we have on that Active Directory. So if I want to use the built-in list of users, the built-in with Nmap, so I'm not gonna specify explicitly a list of usernames. So in here, I have given it the script name, which is Kerberos enumerate users, and the only argument I have given is the domain name. And here, I figured out one account, which is the administrator account. Now, if I have my own list, okay, probably it could be more accurate. So let me run it now with the username list, which is the one I have showed you over here. And maybe it can figure out extra users. So we have David, we have Donald, we have Mark, Mike, John, and Abraham, okay? So these are some of the user accounts that are available on the Active Directory. Now, there are others, but they are, because they are not listed in the in this list, we haven't discovered them. So at least we can take a note of these. Okay, I can extract them, put them somewhere on my note. Okay, so I can come to them later on during my assessment. So this is the first thing. Now, to go deeper into the attacks, it's essential to understand how Kerberos authentication really works, okay? And this is like, it's a simplified diagram of how Kerberos works. And I want you just to remember one thing, that there are 3 pairs of any Kerberos authentication or any Kerberos access to a service or a resource. There are 3 pairs. The first pair, as you can see here in green, this is the authentication request and reply. Okay, it talks to the Kerberos server. Okay, this is the Active Directory. It has a name, Key Distribution Center. This is a Kerberos term. Okay, where you authenticate yourself in the beginning. Okay, so we have, this is the first pair. You send your password in a certain form, we're gonna talk about in a while, and then you get a reply. Next, the second pair is you are going to request for something called ticket granting system ticket. So TGS ticket. And the TGS ticket you requested in order to access ultimately the resource you want to access over here. So this is the Active Directory. This could be like a printer, could be a file server, could be a web server that requires Kerberos authentication, whatever that is. But after you have authenticated, you're gonna request a TGS ticket, okay, from the Kerberos server. And then you're gonna use that TGS, so there is a request and reply, and then you're gonna use that TGS to access the service, okay, ultimately. So 3 pairs, remember, authentication, TGS ticket, and then accessing the resource. Let us dive deeper. Now, each packet of these 6 packets is very complicated and contains a lot of data, and the way it is hashed and encrypted, there are a lot of parameters involved, but we're gonna focus only on the key factors, on the key elements here. So in the first pair, the Kerberos authentication server request, this is here where after you have entered your password, okay, there is something called encrypting timestamp. So a timestamp is going to be encrypted using your own password hash, okay? And this is the default behavior in Microsoft Kerberos, except in certain situations, which we're gonna talk about. So you encrypt the timestamp using the hash of your password, okay, and contains your username and submit it to the key distribution center. Once it verifies it can decrypt the timestamp, then you have the correct password. It's gonna reply, AS reply, okay? It's gonna reply with something we call TGT, ticket granting ticket, okay? This is different than the TGS, which we're gonna see in the next pair. The TGT is a bunch of data that is encrypted by the Kerberos account, okay? This is the most valuable account on any Active Directory. It comes built in with any Active Directory, just like guest account and administrator account. And it is the account that is responsible for running the KDC. So the TGT, the ticket granting ticket that is embedded in the reply here, is encrypted with this account, the Kerb TGT account hash, okay? And only KDC can decrypt and check it. So even though it is given to the user cannot do anything with it. It is only there for the user to send it again so that the Kerberos server can verify it later on. And we will see how in the golden ticket attack, if we compromise this account, we can issue any, we can access any service in the network using the golden ticket, which is the golden TGT, because we have compromised the Kerberos TGT account. So this is the first pair. The second pair now, after we have got the TGT encrypted, we're gonna send TGS request. We will request now TGS. The TGT will be sent along with the service we would like to access, okay? And each service is represented in Active Directory with something we call service principal name. We will revisit this in one of the attacks called Kerberoasting. But in short, service principal name, or SPN, is a conventional name of linking services to users or to accounts, service accounts, so that you can access them through your own account. This is basically what SPN. So you're gonna say, I want to access SPN, let's say printer on that server, and here is my TGT, and if it is successful, if it is verified, you will get the TGS ticket encrypted with the service account, okay? So this is encrypted not with user hash, but with the hash of the service that is running the resource you want to access. Now, why this is important? Because we will see later that in some of the attacks, we can get access to the encrypted TGS and we can crack it offline to get the password of the user account running that service, okay? So this is the second pair, TGS request, TGS reply. Then finally, we have the application request and application reply. Application request and reply is where you go to the server or to the service that you want to access, and you say, here is the TGS that I have acquired, allow me access. It verifies everything, and then it gives you access to the resource you are trying to access. So what are the attacks? If we look at these at this process, the authentication process, number one, if we revisit the first pair, I talked about in the first packet. Let me go back here. In the first packet, in this packet, there is a timestamp that is encrypted with user hash. Okay. Now, this is called the pre-authentication. Pre-authentication. However, pre-authentication is not always required. Okay. You can disable it for any account you want. As you can see here in this snapshot, you can say, do not require Kerberos pre-authentication. And if you say do not require, that means the first packet does not have an encrypted timestamp. Okay. Now, why this is the case? Why Microsoft has introduced this feature? It turns out there are legacy and old applications and old services and systems that you would like to join to your domain do not understand or do not perform the pre-authentication mechanism. So if you disable it for their account, then they will be able to join your domain, and they will be able to actually perform the required task in the domain. But this will open the door to an attack. Okay, the door is any hacker, okay, any user can send a Kerberos AS request on behalf of any of those accounts, because he does not have to know their passwords. Okay, so there is nothing encrypted there, and this packet, the first packet, the Kerb AS request, is gonna look completely legitimate. And because it looks legitimate, the Kerberos server is going to reply with Kerb AS reply that includes certain data encrypted with that user's key, that user's hash, okay, that you are trying to impersonate or trying to send the packet on their behalf. Now, once you get that encrypted data, you can now crack it offline. Okay, you can crack it offline the way you crack any hash offline. Okay, let us look into how to perform this attack, and let me show you exactly on Active Directory. So I'm gonna visit here the Active Directory. This is so if I go to the Active Directory users and computer, any user account, okay, if I right click on it and I go to the account and I check the options here, the last one is don't require Kerberos pre-authentication. Now, out of all the users that I have here, there are two that I have already pre-configured with no pre-authentication. So that means I can send packets on their behalf, requests on their behalf, and then I'm gonna get a reply, portion of which is encrypted using the user's password, the user's password hash, which means I can crack it offline. How do we do this? The way we do it, we have a tool that comes part of mPacket called Get NP Users. NP stands for No Pre-Authentication. So I'm gonna harvest user account that do not require pre-authentication. And then once I acquire those, I can crack it offline using either Join the Ripper or Hashcat. Let us see how we can perform this attack from Kali Linux. Now, remember, our Kali machine is not part of the domain. So you don't have to be part of the domain to perform this attack. Now, in a later account, in a later attack, you need to be or you need to have some username and password. So the get NP users is going to perform this attack. And I'm going to explain something here. Now, I need to give it first a list of users, okay, a list of usernames, okay. I'm going to use the same usernames which I have used with Nmap, from which I discovered these, or I can compile a shorter one using only these accounts, okay. And the format is going to be hashcat, which means the output file is going to be compatible with hashcat. And I'm gonna save the hashes in a file called hash.as.reprost. This is the attack reprost. And this attack, or this file, I'm gonna give it like serial number 3. And then finally, I need to give it the DC IP. And in the beginning, I have given it the domain name. So it is going to send now Kerberos request, multiple Kerberos requests with each of the names in the usernames list. Okay, and it's going to tell me which one has pre-auth enabled, which one does not require pre-auth, and which does not exist. Okay, now most of these do not exist, so client not found in Kerberos. Okay, some of them, the output is going to be like this. If there is a username that exists but requires a pre-auth, is gonna tell me, hey, user John does not have don't require pre-auth set, which means it is immune to AS reprost attack. Now, these are usernames which do not exist. User Mike also does not have don't require pre-auth. The same thing for Abraham. Okay, that means the same thing also goes for Mark. That means the others do have. And since I have specified the file, I can check the file here. AS reprost 03. Yes, there is 3. This is the last one. And here I have 2 tickets. Okay, I have 2 tickets here. The first one is for user David. And then the second one is for user Donald. Okay. Now, if we look at the syntax of the output here, the first portion after the first $sign indicate that this is Kerberos protocol 5, and the packet is AS reply, and then 23. This is the type of the reply. Okay. It turns out it depends on the version of Kerberos. There are different formats and different types. So this is type number 23. And then we have the usernames, and then we have the encrypted portion. Okay. This is encrypted using David's hash or David's password. The same here. This is encrypted using Donald password, which means I can crack them offline. Now, if I have a valid username and password, okay, and instead of giving a list of usernames, what I can do, I can specify that username and password, and then I will do an LDAP query to get inclusively all users without pre-auth. Okay, so here I have an account for user 1, and this can be an insider, a domain insider, okay, inside hacker, or could be I have compromised the password of this users, and now I'm gonna use that user account to actually pull all other users. Now, you might ask, will there be any difference? Yes, because if my username list is not that sophisticated, then I might miss some user account. So I'm gonna call this 04, and it is exactly like the previous one, except that now it has a user here, okay? And I already know its password, so either you can assume we have compromised it, or we are an insider, okay? Somebody who is already part of the domain and would like to perform this attack. So I entered the password, and here I got three additional three users, okay? Donald and David have already been in the previous one, and then user one. So user one that is already here also does not require pre-authentication. So if I cat number 4, I can see 3 tickets. Now, what do I do with these? I can simply crack them with hashcat, okay? And the way to crack them with hashcat is very simple, okay? I will explain each of the parameters here. So hashcat, the first thing I need to give it the type of the hash or the type of the encrypted data. Now, if you check the help of hashcat, what you will see, it has a list of different hash formats which it can cracks. So here it has a lot of formats, password format it can crack, and each format has a code. Each format has a code over here. Now the code for Kerberos 5 AS response is 18,200. So with this code, it's Kerberos 5 E-type 23 AS rep, which is exactly what we want. So hashcat minus M, this is the type, 18,200. And then with force, I'm gonna ignore all warnings. And it has different modes of operations. You can give it either dictionary attack, hybrid attack, brute force attack. If we say 0, 0 means it's fully dictionary attack. And then I'm gonna give it the hashes as reprost 02. This is the second one. And then I'm gonna use the fast track dictionary. You can use RACU if you want. I'm gonna use fast track just to avoid any time latency, because RACU is a huge file, but fast track is very quick file. So if any of the passwords of those users, Donald and David, exist in the fast track, it should be able to crack them. Of course, for offline cracking, we always recommend using the RACU dictionary. It is more sophisticated and has a lot of options and a lot of passwords. Any question, guys, so far? Any question on the AS rep roast attack? Okay. All right, good, thank you. So while waiting for the crack to be done, we have explained now the command and the hashcat and how to crack them. Let us move on to the next attack, which is Kerberoasting. Okay, keeping an eye on the on this one. Okay, so as reproast, we said as reproast. Okay, it cracked both of those passwords. So David's had the password of winter 2010. So I'm going to copy it, put it somewhere here. This is David's. And then we have Donald with this password, copy. Now, given you have those passwords, you can easily now log in to Windows 10, that is domain joint here, using any of the cracked password. Let us verify that. So we have David, winter 2010. David 2010. Good question. Good question. Somebody is asking, can complex passwords be easily cracked too? Of course, complex passwords cannot be cracked as easily. Okay, the more complex the password, the longer it takes. And one of the mitigation strategy we're going to talk about at the end is having a very sophisticated password policy. Okay, so the stronger the password, the stronger your password policy is, and the frequency of changing the password all plays a role in mitigating those attacks. So I was able to log in. So the AS reproast, what I need you to remember, AS reproast targets accounts that does not require pre-authentication. Okay, target accounts with no pre-authentication. Another attack here is Kerberoasting. Kerberoasting is even more famous. The first one, no pre-auth authenticate, pre-auth is rarely enabled. Okay, if you have a network with sophisticated devices and no legacy devices, you might not be able to perform that. But with Kerberoasting, you have a higher chance of successfully doing it. How do we maintain the access? Maintaining the access is another topic by itself. What you need to do now, okay? What you need to implement to maintain the access, the backdoor, this is by itself, this is another topic probably for another webinar even. Already have premium enabled, or is it caught and stopped? I'm not familiar with AD Premium enabled. However, Microsoft has added in later version of Active Directory certain features to mitigate those attacks, and we're gonna talk about one of them, which is changing the Kerb TGT passwords. Okay, and even we have something we call Managed Service Account (MSA). Okay, this also helps mitigate the Kerberoasting attack. So, what is Kerberoasting attack? To understand Kerberoasting, okay, we need to understand something in Microsoft terminology and Microsoft Active Directory, something called SPN, Service Principal Name. Okay, in Active Directory on a Windows domain, you might have services such as, let's say, web server, Apache service, IAS, you might have a Microsoft SQL service, you might have MySQL, whatever you can think of as a service that is running, okay? And sometimes services require authentication, and a domain administrator may add a user account for that service to authenticate. Okay, once you add it, okay, you have the option of identifying that service in the properties of that user account. So here, for example, if you check this one, I'm gonna enlarge the size over here. If you check this calc service, okay, this is the calc service. I have created it as a service. I have the option to define which account it's running as, okay, which account is running as. And here I am running it as Mike. So it is using my credentials for it to authenticate to the domain and to actually perform its tasks. Now, I can go to Mike properties and add an SPN stating that Mike is associated. This is the attributes of Mike. I can say Mike has the SPN of calc on that Windows server. Okay, I can define any server in the domain. So that means I know that Mike is running, that calc is running under Mike account. Now, what is the problem with that? The problem with that, here is a simplified version. So we have the service calc running on this machine, and it's logging in with Mike account, and then the user Mike has an SPN stating that calc under this machine is running using this account. How the attacker can compromise this? The attacker first, for Kerberoasting to function, you need to acquire at least one domain account. So this is suitable. This attack is suitable if you are an insider, or if you have already compromised one domain account. So let's say attacker compromises account user 1. Then next, attacker authenticates to the Active Directory using the password or the credentials of user 1. Okay. And then after performing the first pair, on the second pair is gonna say, I want a TGS ticket to access calc. Okay. Now the TGS that he is going to receive, portion of it will be encrypted with Mike's hash. So now user 1, the hacker, has gained an encrypted portion with Mike's hash or Mike's password. That means I can, using hashcat, I can crack that data and recover Mike's password offline, if it is crackable, okay? If it is not that complex, or if time allows me to perform that. So just like the get NP user that we used previously, we have here a script, a Python script, part of Impacket, called get user SPNs. Okay, it's a script that if I run, I can acquire a list of users that have associated services or SPNs. Okay, and then I can acquire TGS tickets encrypted using those users' password, and then I can crack them offline. Okay, let us do this lab and see what passwords we can now compromise. So we finished the get NP users. Let's go to the get users NP. Okay, now as I said, you need to have at least one domain account to perform Kerberoasting. So copy. So what I did here, this is the command get users SPN. Okay, the function is request. This is the DC IP. The output file is going to be hashes Kerberos. I'm gonna call it here. I'm gonna give serial number 3 to distinguish it, and then I'm gonna give it the domain name and one user account that I have already have access to. Okay, so enter. this is the password of user one, which I have compromised, or which is my account if I am an insider. And here I got the SPNs of different users. So user one has an SPN HTTP, okay, it's a random one. Then we have a username called MSA syslab1 that has this SPN, which means it has access to the service gen service on this machine. Then we have user mark that is associated with the Chrome service on this machine, and user mic is associated with service calc on this machine. Okay, I haven't demonstrated how you can configure SPNs on Active Directory and how you can connect user with services, because this is like beyond the topic today, but I can show you if anyone would like to know how this can be configured on Active Directory. At the end of the webinar, I'm gonna share my email address so you can contact me, and then I can reveal the steps to create that. So Muhammad is asking, can the Active Directory server block the extraction of SPNs from a certain user, say user one, and have the same? Or no. The thing is, SPNs are accessible to any domain users. Okay, if you have a domain user, user one or whatever, even if it is non-privileged one, then you can access SPNs. Okay, this is plain text. This is normal, because ultimately you might use those services. Remember, the Kerberos server, the Kerberos Active Directory server, is not responsible for authorization, meaning if the printer, let's say printer A, allows you to access it, that permission is assigned on the printer itself. The Active Directory really doesn't care if you have access to the printer or not. It gives you the ticket, and then you send the ticket to the printer, and then the printer, it's up to the printer to accept you or reject you. Okay, so that's why SPNs are already accessible. Okay, you cannot really do much about them. The only thing to prevent this attack, as I'm gonna show at the end, is really strong password policy. Additionally, if you want to complement that, you can add something we call honey accounts. Okay, honey accounts as a trap to catch malicious users. So since I have gained those SPNs, I have gained TGS tickets encrypted with mic password and mark password. So let me, if I cat hashes Kerberos 03, I can see here multiple, like I can see mic over here, I can see mark over here, okay, MSA over here, and then user one over here. Okay, so it contains four tickets. Now remember, if we check here, this is Kerberos 5 TGS. Okay, Kerberos 5 TGS. What was the previous one? If you remember, if you recall the previous one, it was Kerb 5 ASRIP. Okay, ASRIP authentication server reply. This is TGS. Okay. So if I want to crack it now, the only thing that is going to differ with the hash cat is the code of the hash. Unlike the previous one, which was 18,200, this one is going to be 13,100. So this is the exact command that I want to use. Okay. So the hash file is Kerberos 3. And then instead of 18,200 for ASRIP, I'm gonna change it to 13,100. Unfortunately, the system is running slow because I have 3 large VMs. So 13,100. This is the code. If you try to grab the help menu, you will see this is associated with TGS Kerberos 5. So let me attempt to crack it now. So any question regarding Kerberos now? Okay, any question? So in the ASRIP, I targeted account with no pre-auth. And in Kerberos, I targeted account, user account with SPNs. Now, the only difference between the two is with Kerberos, I need to have a valid account. Now, look at here. I managed to crack Mark passwords, okay? And here is his password, company123. So let me type it here down. So my password is company123. So at least I managed to crack 3 of those accounts, okay? Not bad after all, not bad. I cracked them offline, which means I evaded any lockout mechanism that can be implemented, okay? I have not generated any noise, so I stayed under the radar so far. So, any question regarding Kerberos? All right, let's move on now to something that is critical, okay? Let's say you have gained physical access to the machine, to the Active Directory itself, okay? This is the Active Directory. You have gained physical access to it, or you managed to compromise the domain administrator account, okay? You managed to compromise it, but you don't want to delete it, you don't want to create any noise, you don't want to leave traces. You want to get the database of all user hashes and passwords and simply export it to your Kali Linux and try to crack it offline. Okay, how do you do that? First of all Active Directory users and passwords are stored in a file called ntds.dit. Okay, now if you remember, or if you know, local Windows accounts are stored in a file called SAM, the SAM database, okay? The SAM database on Active Directory also contains only local passwords. Now, all Active Directory or domain accounts are stored somewhere else, are stored in NTDS, okay? Under this folder. Now, just like with SAM database, this file is always locked, okay? What does it mean it is locked? You cannot really copy it, you cannot open it, you cannot read it, you cannot do anything with it. So how do we grab it then? This is the file, ntds.dit, okay? How do we grab it? Windows has a feature called volume, shadow volume, and the shadow volume is a copy of data, okay, that is done in real time, and Windows can update it if the original data has changed, okay? So we will use that to copy the entire hard disk, okay, and then access the NTDS from the shadow volume. Okay, the command is really simple. You need to go to run CMD as an administrator, and then issue the command vssadmin volume shadow service administrator. okay? And then create shadow, okay? And then for C drive. So I'm gonna create a shadow volume, okay, from the C drive. Once the volume is created, I can grab the NTDS file from that volume, okay? Now, beside the NTDS file, I also need to grab system file, which contains the sys key. This is the key that can decrypt the hashes, because the hashes are stored in encrypted format. Okay, so I need to grab another file. Now, as you can see here, the volume name, we have this long name over here. Now, this is my copy. I need to access this and grab my NTDS. So simply I need to do copy, give it the source. I need to enter Windows. So this is like the C volume. So Windows NTDS NTDS.dit. Now, in order for it to be successful, I need to copy it somewhere else. So to a destination. So I need to prepare a destination. Okay, let me prepare a destination over here. I'm gonna call it dist for destination. And so C dist and ntds.dit. So it's gonna copy it. Now it's copied. You can see it here. It has already been copied. NTDS. I also need to copy the system file. The system is available in the config directory. Okay, somebody is asking about the list to harden Active Directory and mitigation techniques. At the end, I'm going to talk about mitigation techniques. Yes. System 32/config/system. Okay. This contains a key that will decrypt the hashes. So I copied it here. Okay. Once you copied them, you can really transfer them to your Kali Linux now. And you can do all the nasty thing from your Kali Linux, okay? I have already transferred them using WeTransfer before that, so a copy of them already present at my Kali machine. But I need also to get something very important, which is the domain SID, the security ID. You know that every domain account has something we call security ID. And the portion of that security ID is common for all users. This is the domain SID. And the way to get this, I'm gonna use wmic and with user account parameter. Okay, if I type enter, okay, I can get all of these IDs. Do you see those IDs? S1 521, blah, 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 blah. Now, until this part, to highlight it, this is a common part for all users, okay? If you check each user here, they have the same part. Only the last portion, 501, 502, 1000, 1100, 1108, and so on. So I need to copy the common portion, the portion that is common between all of them. This is the domain SID. I needed to perform my golden ticket attack. So I assume I have copied it. It is listed here. This is the one. I have already copied it. Okay, let me go back now to my Kali Linux and see what we can do with it. Part of Mpacket is a tool called secrets dump, okay? And with secrets dump, I can, so let me show you the NTDS. So I believe I have a folder here called NTDS. So anti-DS. Okay, this is the system, and this is the anti-DS DIT. Now, with secrets dump can access the anti-DS, decrypt the hashes using the system key, and then output them for me in a file. So secrets dump, the anti-DS, I give it the anti-DS file, anti-ds.dit, and then the system file over here, and then the type of hashes. Remember, there are two hashes for each password, for each user, the LM hash, LAN manager, and the NT hash. So I need both. And then the output, I'm going to give it the output. I'm going to change this. So I'm going to call it hashes.nt03. And then local means this attack is going to be performed locally, the extraction locally, because secrets dump, if you give it username and password, can access a remote system and grab the hashes if you have privileges. So it's going to extract the hashes and save them in a file called hashes.nt03. Any questions so far? Do you have any question regarding extracting domain hashes? Ibrahim is asking, in hunting perspective, what to check on anti-DS manipulation. Remember, if the hacker got your anti-DS, you know, the problem is not getting the anti-DS because he already got there. The question is, how did he get there? Okay. He either got physical access, okay, and physical access means I can get the anti-DS. He either compromised the domain administrator, okay. So he has done a lot before grabbing the anti-DS, okay. And the hunting should be prior to grabbing the anti-DS or the manipulation of anti-DS. It's how really you should secure your domain and domain administrator account. Okay, so we extracted the hashes, okay. And if I do cat hashes.nt03, okay, here are the hashes for the administrator, for the guest, AWS, the computer account. And as you can see here, the Kerb TGT. Remember, I told you the Kerb TGT is the account that is running the entire KDC, the entire Kerberos server. Okay, it is the most important account. And if I get its NT hash, guess what I can do with it? I can forge my I can force a TGT, a ticket granting ticket of my own. And then there is no way for the Kerberos to assume or to know that I am not part of the domain, or I don't have privilege in the domain. With TGT, I can trick with TGT, sorry, with Kerb TGT hash, I can create a TGT to trick the Kerberos server that I am any user or service in the domain. So I can impersonate anybody with that TGT, okay? That's why the next attack is called golden ticket attack, okay? There is another attack called server ticket, okay? I'm not gonna cover it, it is limited, okay? But if you understand the golden ticket, it's very easy to understand the silver ticket. So we will talk about the golden ticket here. And this will be like the last attack before talking about the mitigation. Remember, in a normal Kerberos authentication process, there are three pairs. The first pair is the AS request, and then you get AS rep. In the AS rep, in order actually to get an AS rep, you must have, of course, a correct username and password. And then the AS rep contains TGT, okay? And the TGT is encrypted with the KDC account hash. And then you will use that TGT in the next pair, okay, to query, to ask for a TGS. Now, since I already have the hash of the Kerb TGT, I can create a TGT ticket, okay, and simply jump directly into step number 3. So I skip step number 1, I skip step number 2, and then I go to step number 3, and I send that TGT, that encrypted TGT, encrypted with the Kerb TGT account hash, which I cracked. Now, the moment I send this, the user, and then I can claim to be anybody. I can claim to be, I am Mike, I am John, I am David, I am anybody in that domain. And the KDC is going to believe that I am already authenticated as that user. And then I'm going to grant, I'm going to be, I'm going to have access to all the privileges that this user I am impersonating, the privileges he has, okay? This is in essence what the golden ticket is. Now, the prerequisite for a golden ticket attack is you need to have anti-hash, okay, of the Kerb TGT account. This is the holy grail, okay? If you get it, you can form the golden ticket, okay? And as you can see, we have already done it. You need, of course, the domain name. This is very easy. And you need the domain SID. Okay, I have already showed you how to get the, using WMake user account, how you can get the domain SID. Copy it to your Kali machine, and then the fun can begin. We have a tool which is part of the M-Packet tool called Ticketer. And Ticketer enables me to create either silver ticket or golden ticket. And we will use it here to create a golden ticket. Remember, if you recall here, I managed to crack David. I managed to crack Mike. I managed to crack Abraham, okay? But I haven't cracked, let's say, Mark, okay? I wasn't able to crack Mark, but let me impersonate Mark using golden ticket, okay? Let us impersonate now Mark. So I'm gonna copy this. Now I'm gonna modify this from Abraham to Mike, just for it to change something. So paste this. Let me explain now. This is the tool, Ticketer, part of M-Packet. This is the anti-hash of the Kerb TGT account, which is I have extracted from here. So this one is the one over here. Okay. This is the domain SID, which I have acquired from the Active Directory. Okay. This is the common one between all users. And of course, this is the domain, and then the DCIP, and then the username, which I would like to personate. So I'm gonna forward this TGT to impersonate Mike now. Okay. So impersonate Mike. Mike. Okay. I got a ticket for Mike. Okay. And it is stored in Mike Ccache. Okay. I can now use that Ccache, which is the ticket, to access a domain server as if I am Mike, okay, without knowing his credential, okay? And for that, I'm gonna use another tool. Let me just, there is one thing I need to do. I need to export to create environment variable, okay, Kerb5 CC name with the ticket name. Why this is important? Because the next command, which is the ps exec command, instead of giving the password of Mike, I'm gonna tell it to access the C cache exported in this parameter and use it for authentication. So with ps exec now, so ps exec is also a very powerful tool. If you have a valid credential, either a valid credential or a valid ticket, you can use ps exec to execute any command you want on the system on which you can log in with that username. Okay, so I'm going to access now Windows 10. Windows 10 is the desktop NRC. This is the name. Okay, with the username Mike. So I need to change Abraham here to Mike. Sorry. Axon. Okay. Minus K means it's Kerberos. Minus N means no password. So it is not going to ask me for the password of Mike, but rather it is going to use the Ccache file, which contains the ticket. And at the end, I can give it the command I would like to execute. And in this case, I want to execute CMD. So I want to get full CMD. I have got now CMD access using Mike. So ipconfig ipconfig -all. Basically, I have CMD access on the Windows 10 machine. I am now accessing it using Mike account. Okay. This is in short. This is using the golden ticket. Now, since I have, like, let us access it using David and this password, which we have compromised before. So if I exit this one, and then I try to access using David, okay, I need to remove the no password. I need to enter the password, which is winter 2010. So winter 2010. More processing required. Okay. Maybe something is missing. Okay. I will leave this, but I have not tried this before, but I have demonstrated, if you remember, that you can access the machine directly with the username and password. Okay, if you remember, we have accessed it using, I believe, David and probably Abraham. Okay, but you can also use ps exec to perform remote execution of attacks. Anyways, the idea, the summary here is if you can forge a TGT, you can access systems using that user account without knowing its password, without knowing his password. So let Let me move on to the mitigation techniques. There are simply 4 simple mitigation techniques, and we can close this webinar. We are coming to the end of it. The first thing, you should never use the don't require pre-auth attribute, okay? It is there for legacy systems. However, we should not really have legacy system. If you really care about security, then the systems and services you install in your network need to comply with the security policy. You should not lower your security so that you meet a service that is like not well written and not well developed. So never use don't require pre-auth attribute. Keep everything in your network, every account with pre-authentication. Okay, this will eliminate any AS Kerberos attack by itself. The second one, implement a strong password policy, especially for service account. If you have a password policy for users that the minimum password, let's say, is 10 characters, 12 or 14 characters, then for service accounts, you should have passwords more than 24 characters or 30 characters, okay, or even longer. Because for service accounts, you have SPNs, okay? And SPNs, remember, Kerberos is a very powerful attack for somebody who is inside the network to perform. So, and SPNs are associated with service accounts. So any service accounts, if you want to run service accounts, then make sure the policy is stronger than the policy for normal users, okay? And you need to edit user accounts. You need to check their behaviors, okay? Because remember, Kerberos requires a valid user accounts. So you need to make sure none of the users you have in the domain is actually compromised. So strong auditing on user accounts so that you spot any compromised user account early on. Number 3, implement what we call honey account. Now, honey account, you can create 2 or 3 of them. These accounts are not used for anything except to alert you if a hacker is there. So once you see a log that one of the honey accounts has logged in, okay, or has accessed a service, then that means you are compromised. That means a hacker is doing that. So it gives you a sure way of a compromise, because a honey account, you make them and no one legitimately on your network is using them. So any sign of usage of a honey account is a sign of compromise. So a hacker compromises a honey account and then try to access the Kerberos in order to do Kerberos account or any other accounts. So honey account is something you can consider. And then finally, in order to prevent golden ticket attack, consider changing the KERB-TGT password regularly, okay? Now the KERB-TGT password, you can right-click and reset it over here, as you can see, just like you can do it for any account. However, the password you enter is not the actual password that's going to be used, because the system is going to create a very complex password out of that entered password. So the one you enter does not really matter. But what matters is you need to do it twice. So let's say you have a policy to change the KERB-TGT password every 3 months. Okay. After 3 months, you want to change it. You do not change it once. You have to reset and change it twice. Why is that? Because if you change it and then a hacker has the older password or the older hash, Kerberos, when it tries to decrypt the TGT and then the current one fails, it's going to revert to the previous one in history. Okay, so in order to erase the history, you need to change it twice so that you eliminate any previously compromised hash. Okay, and somebody from Microsoft has even written a script called reset kerb tgt key interactive. It's a PowerShell script. I have given the link here. Okay, and it simply does that for you on your behalf. So you simply schedule it to run every 3 months, and that's it. It will automatically change kerb tgt password on your behalf, and this is applicable on Windows Server 2008 up to the most recent one. Okay, so that was all, guys. Thank you very much. If you have any question, please write it on the chat. I'll be more than happy to answer you. I'm sharing here my email address. If you have any question you would like also, or you have any feedback, you can write me on my email address, aws@axontechnologies.com. And again, I'm reminding you of the link where you can find the recording and all the previous recordings. This is number 7. So we have now 7 episodes. We are like more than half a year so far. Hopefully we can complete 1 year also. We'll celebrate at the episode number 12 together. So any question, guys? Thank you again. Thank you for your time. I really appreciate it. Looking forward to see you in previous webinars. Maher is asking if the recordings are saved. Yes, if you go to the link that is shown here, all the recordings are saved, yes. Yeah, Muhammad is sharing the link. Okay, thank you for that.